Hey guys, this is Raj Vashi and we're gonna be doing lesson 7-6 polynomials. So before we start off, let's take a look at the vocabulary. We got words like monomial, degree of a monomial, polynomial, degree of a polynomial, standard form of a polynomial, leading coefficient, quadratic, cubic, binomial, trinomial, and root. So, let's see, what's a monomial? A monomial is a number, a variable, or a product of numbers and variables with whole number exponents. A monomial may be a constant or a single variable. So here's a few examples, like say 5, that's a monomial, just the number 5. X, that's a monomial too, just x. Negative 7xy is a monomial. Now people say, like, some people make a common mistake of thinking that this isn't monomial because there's a negative sign there. That negative sign doesn't matter. It's just saying that it's negative 7. It's not minusing anything, it's just there. 0.5 x to the 4th is a monomial, because there's no negative signs, there's no addition going on or subtraction, so that's monomial. Here's some non-monomials. Is negative 0.3x the negative second power? That negative sign doesn't matter, that one does, because it's a negative exponent, therefore it does not count. This 4x minus y, it doesn't count because it has a minus y in it. It's 4x minus y. They're subtracting y. 2 over x to the third, that's not a monomial because it's divided by. So those are all not monomials. These are all monomials. So here's a few more. Say 3x squared. That is a polynomial. Yes. Because it's just 3x squared and there's nothing being subtracted, added, there's no negative exponents. Exponent is a whole number, so it counts. 10y, again, yes. Because it's just 10 multiplied by y. No addition, no exponents, it's all good. 5, we already looked at this one, it's yes, just one number. Now this one, 7 to the 10th plus 5, no, it has plus 5, that's not a monomial. Negative 8.5 minus x, no, negative 8.5 x minus 2. The negative sign is fine right there, but this minus sign isn't, because it's 8.5x, negative 8.5x, minus 2. So, no. 10.5 minus 4. That isn't monomial because it's subtracting 4 from 10.5. So, yeah, no. Those are all monomials. Let's take a look at finding the degree of monomials. So here you can see that these are two monomials split. If you split them right down through here, it's negative 2a squared times b4, b to the 4th. So these are two polynomials. Now how do you find the degree of this entire thing? Well, what you would do is you would take the two exponents of the monomials and add them together. So you get 2 plus 4 equals 6. So 6 is the degree. So now that we know that, let's take a look at a few more. So say that I gave you the number 4. How would you find the degree of that? I mean, it's one monomial. So you would do is you would add an x and then give it the power of 0, because anything to the power of 0 is 1. So say 4 times 1 is still 4, so it's all perfect and pretty good. So the degree would be 0 because it's the exponent there. So that's the degree. So the degree is 0. Now how about 8y? Now there's no exponent again. So what you would do is that you take 8y and give it the first power. So after that it's 8y to the first power. Now the degree would be the exponent, right? So the exponent is 1, the degree is 1. So now how do we find, well, first of all, how do we write polynomials in standard form? The standard form of a polynomial contains one variable and is written with the terms in order from greatest degree to least greatest degree. When written in standard form, the coefficient of the first term is called the leading coefficient. So, say we had 2x minus 4x cubed plus 2 minus x to the second power, or squared. So what we do, we would give them all, we just write down their degrees. So this is to the first degree, there's no exponent, you learn how to do this here. And then this one is to the third degree because it's cubed. This is to 0 degree because there's no exponent or variable. And this one is to the second degree because it's squared. So now you have them, line them up, and you get negative 4x squared plus 2x plus 2. And you'd get the leading coefficient of negative 4 because it's the first coefficient that's there. So now let's look at classifying polynomials. First of all, there's like a ton of names for polynomials. I'm going to show you those from some from the book. So if the degree is 0, it's called a constant. And if the degree is 1, it's a linear. Then if it's the degree is 2, then it's quadratic. It's one of our vocabulary words too. It's highlighted in yellow. And so then if it's 3, it's cubic. And if it's 4, it's quartic. And 5, quintic. 6 or more, it's the 6 or more, 6th degree, 7th degree, and so on. And for terms, it would be, for one term, monomial. We know that. For 2 terms, binomial. 3 terms, trinomial. The roots bi means 2, tri means 3. And 4 or more, polynomial. So now, let's get back to working. Oh wait, first, examples. Okay. So, here they have examples like 5x minus 6. So the degree would be 1, terms would be 2. So, since the degree is 1, it would be called a linear polynomial. And then since the term's 2, it's binomial. So it's a linear binomial. And it says that here, 5x minus 6 is a linear binomial. So, then again here, y plus y squared plus 4. The degree is 2 because 2 is the only exponent in the entire thing. So, degree is 2, and there's 3 terms. If there's 3 terms, it's trinomial. So, and since it's 2, since the degree is 2, it's a quadratic trinomial. And it says that here, quadratic trinomial. And then here, 6x squared, 6x to the 7th plus 9x squared minus x plus 3. So degree is 7, So it would be 6 or more, so 7th degree. And terms 4, so it would be a polynomial. So here it says it's a 7th degree polynomial. Here we got n cubed. The degree is 3 because it's the only exponent here. And then terms, there's only one term, it's a monomial. So it's a cubic monomial. See, right here. Cubic monomial. So here's some more examples. X plus 3 to the 9th plus 8. So we have, it's to the 9th degree, so 9th degree. And it has 3 terms, so it's a trinomial. So it's a 9th degree trinomial. And there's your answer, 9th degree trinomial. So now let's look at another one. So say if we got x to the 5th. Now it's to the 5th degree. And it is a monomial, so one term. So that would give us a quintic trinomial. Monomial. So there's your answer for that one. Quintic monomial. So now let's look at identifying roots of polynomials. So a root of a polynomial is in one variable is a value of the variable for which the polynomial is equal to 0. So basically what they're trying to say is, so if I gave you a polynomial like say 2k squared minus k minus 3, and I told you tell whether each number is a root of that. So I would give you a number, and you would pretty much just plug it in for the variables, and you would see if it equals 0. If it equals 0, it is a root. But if it doesn't, then it's not a root. So in here it says, so they give you a number 4. So they give you that, and you plug in 4 for k, and you get 2 times 16, because 4 was squared, minus 4 minus 3. So then you get 32, because 2 times 16 is 32, minus 4 minus 3. That gives you 25, because 32 minus 4 is 28, and minus 3 is 25. So 25 is not equal to 0. So 4 is not a root of 2k squared minus k minus 3. So now, say if we gave you negative 1. So 2k squared minus k minus 3, sub in negative 1, and you get 2 times 1, because it's negative 1 times itself, so squared. Cancel out the negative. 2 times 1 plus 1 minus 3. So you get 2 plus 1 minus 3, which is 0. So negative 1 is a root of 2k squared minus k minus 3.